video will cover section 1.7 on inequalities, and we're going to discuss specifically linear inequalities. So remember, when we were looking at linear equations, there was an equal sign, and it said something to the effect of x equals some number. I'm just going to pick a number, 5. Notice that x only equaled that 5. There was only one solution. Now with linear inequalities, they can have multiple solutions, actually up to infinite amount of solutions. Alright, so if you look on page 147 in your textbook, there's a chart that's going to describe how we're going to write the multiple solutions, and there are a variety of ways to do it. Alright, and we're going to look at a couple of those ways down here below. Linear inequalities are solved in the same way as linear equations, with one exception. In linear equalities, when you divide or multiply by a negative, you have to reverse the inequality sign, and dividing by means the negative is down here in the bottom. It's what I'm actually dividing by. It does not matter what I'm dividing into. I can divide into a positive number, I can divide into a negative number. That will not change the sign, only if the bottom is negative. So whatever I'm dividing by has to be negative. Or if I multiply by a negative, then we're going to reverse the inequality symbol. Alright, so if we think about what the inequality symbols are, alright, they look like these: less than, greater than, less than or equal to, greater than or equal to, and the other one would be not equal to. Alright, and so you can read the inequality from left to right or right to left. It doesn't matter. Whichever side of the inequality symbol you come to first, that is the side you should say. So for example, if I'm reading this would be x, and because I come to the small pointy side of the inequality symbol, I'm going to say less than 3. But if I were reading it from right to left, I would say 3 is, and because I come to the wide open part of the inequality, I would say greater than x. 3 is greater than x, or x is less than 3. So whichever way you want to read it. Now if you see this where the variable's on the left, less than 3, alright, there are a couple of ways we're going to write our answer. One of which is to use a number line and graph all of the solutions. So what this means is that x can be any value that is less than 3. Alright, well, how many numbers are less than 3? 2, 1, 0.5, 1.25, negative 0.33, negative 10, negative 1,000, and I could keep going on forever in listing numbers that are less than 3. So if we were going to graph them on a number line, you can just draw a basic number line. Alright, make sure you draw a line, and on each end put an arrow. Those arrows say it goes on, keeps continuing in that direction. So here we would be continuing to the left, or the negative direction. Here we would be continuing to the right, or the positive direction. And the way that we say in the left direction would be negative infinity. So we say it continues on forever in the negative direction. If it's continuing on forever in the right direction, then we say that is positive infinity. And if you can't draw the infinity symbol, then just turn your paper sideways and draw an 8. Alright, so continuing to the left forever is negative infinity. Continuing to the right forever is positive infinity. Remember on the number line that as you move to the left, numbers get smaller, and as you move to the right, numbers get larger. Alright, so to graph on the number line, I'm going to draw me a number line, put arrows on each end. Then I'm going to take and mark this number right here on the number line. Now, you don't have to be fancy with your number line, just a plain number line like this, and somewhere on there mark you a 3. It doesn't matter where, it doesn't matter how long your number line is. Alright, and then what we want to show is on this number line where all the values are less than 3. So if I'm thinking about 3 and I want to know what's less than 3, that means the numbers are getting smaller. Alright, that would be anything that's to the left of 3. So I'm going to, on my number line, shade everything that's to the left of 3, including that arrow. Okay, so anything to the left of 3 is smaller than 3. I'm going to shade it. Now, when you may have learned about inequalities, you may have, for these two symbols, used an open circle. And then for these symbols, you may have used a closed circle. All right, well, we're going to no longer use those. All right, because we're going to also be writing our answer in interval notation, which requires brackets and parentheses. So now when we graph on the number line, if you have less than, you're going to use a parenthesis, and if you have greater than, you're going to use the open parenthesis. So this is closed, this is open. All right, and then if it's less than, you're going to use a close bracket, and for greater than, you're going to use an open. I did those backwards. This should be this, that, and then an open bracket. All right, so a closed bracket and an open bracket. All right, so for this one, we have less than. What these parentheses say are, do not include the 3 as part of the solution set. If I fill in a 3 for this x, it makes a false statement. 3 is not less than 3. So I can't include 3, but I can include anything up to 3, such as 2.999999999. I can continue on with the 9s forever, but I'm not at 3. So I'm going to put a close parenthesis there. All right, for interval notation, what this says is what is the smallest possible value x can be up to the largest possible value x can be, and then anything in between these two numbers is a part of the solution set. All right, it's always the smallest value first, comma, the largest value second. All right, so if you will look at your number line, whatever you have graphed starting on the left, so follow your number line until you start seeing where you shaded, that should be the first thing. And then whatever you shaded furthest to the right, that should be the second number. So your interval notation and your number line should match up. All right, so if I want to write this in interval notation, all right, this arrow represents negative infinity and then up to 3. There is a parenthesis on 3, and infinities are always parentheses. They are never anything else. All right, always a parenthesis on negative infinity, and then if I don't have the equal to part, I'm going to put a parenthesis on the number also. All right, for the next one, that says x is greater than 3. So I'm going to draw me a number line. I'm going to mark me a 3 on there. All right, this time I want to show all the numbers that are greater than 3 or bigger than 3. And the numbers get larger as you move to the right. So I'm going to shade everything to the right of 3, including the arrow. And then it doesn't have the equal to part. That says do not include 3 as part of the solution set, just everything bigger than 3. So now when I write this in interval notation, if I start at the left and move towards the right, the first thing I encounter that's shaded is the number 3. So it is smallest. So I'm going to follow my shading, and I hit the arrow, which represents positive infinity. There's a parenthesis on there. Infinity, always a parenthesis. All right, for the next two, I have less than or equal to and greater than or equal to. That little line under there represents the equal sign. So what this says is that x can be any value that is less than 3, or it can also be 3. So 3 or less would make this a true statement. So you could pick 3 or anything less than 3, fill it in for x, and make that a true statement. So if I draw me a number line, somewhere on there, mark the number 3. All right, this says less than, so I'm going to shade all the numbers that are less than 3. All right, this time it has that equal to part. That says include 3. That 3 can be a part of the solution set. So if I plug a 3 in there, is 3 less than 3? No, but 3 is equal to 3. So I do want to include 3. So I'm going to put a bracket on it this time instead of the parenthesis. Alright, so if I want to write an interval notation, if I start on the left, the first thing I encounter that's shaded is negative infinity. Infinities always have a parenthesis. And then I follow my number line, and the last thing that's shaded is a 3. It has a bracket on it. I'm going to put a bracket on it in my interval notation. For x is greater than or equal to 3, I'm going to draw me a number line, mark my 3 somewhere on there. You don't need to do any other labeling. And I'm looking for all the values that are 3 or greater. So if I plug in 3, 3 equals 3. And if I plug in 4, 4 is greater than 3. So all of those values work. So I'm looking for everything bigger than 3. I'm going to shade to the right. That's where numbers get larger. And then because of the equal to part, I'm going to put a bracket. Writing it in interval notation, the first thing that I have shaded is a 3. There is a bracket on it, and I'm going to follow, and I end up at the arrow, which represents positive infinity, always closed with a parenthesis. If you ever have negative and positive infinity, negative infinity will always go first, positive infinity will always go second. Alright, so let's look at a couple of inequalities here. Let's solve them, graph them, and write our answers in interval notation. So if I want to solve this, it works just like a linear equation. I'm going to get variable terms on one side, constants on the other, simplifying where necessary. So I'm going to subtract 7 from both sides. Alright, this inequality symbol here we treat just like if it were the equal sign. I am left and right of it. So negative 5 and negative 7 make negative 12. I'm then going to divide by negative 2. Alright, at this point, the bottom, what I'm dividing by, is a negative. So that means instead of less than, I will now have greater than. Alright, so when you divide by a negative, you reverse the inequality symbol. It's less than, I'm going to change it to greater than. Negative 12 divided by negative 2 is 6. Alright, so what this says is that x can be any value greater than 6. So if I draw me a number line, mark a 6 on there, all the values that would be greater than 6 are to the right of 6. Alright, there's no equal to part, so this gets a parenthesis. Then I can just, for interval notation, just match it up. So the first thing that I've shaded is 6 with the parenthesis. I follow it until I finish the shading, which is at the arrow. That becomes positive infinity, always closed with a parenthesis. Alright, for this one I want to solve it. I'm going to move the 2x over, and then I'm going to move the 3 over. Alright, so now I have 4x's minus 2x's is 2x's less than or equal to 8 minus 3 is 5. I'm going to divide by the coefficient of the variable term. I'm not dividing by a negative, so my inequality symbol is not reversing. Alright, and I'm just going to leave it at 5 halves. No need to change it to anything else. So then when I graph it, I just come over here to my number line and mark 5 halves. Alright, and I'm looking for everything that is less than 5 halves or equal to it. So less than says to the right, to the left. I'm looking for numbers that are smaller than 5 halves. And I also want to include 5 halves. That's what that equal part means. So I'm going to put a bracket on the 5 halves. Then when I write my interval notation, the first thing I've shaded is negative infinity. Always has a parenthesis, and I've shaded it up to 5 halves. Close it with a bracket.